Hello, today we're going to look at a topic in solid mechanics, shear force and bending moment diagram. So I have a question and I'm required to find the shear force and the bending moment diagram. So I shall start by drawing the free body diagram of this sketch. So that is going to represent my rod. At this fixed end, I'm going to draw a reaction force and I shall name it RA. At this point, the end is placed on top of rollers, and I'm also going to input a force RB. Then I include the forces given in the question: 2 kilonewtons, 4 kilonewtons, and another 2 kilonewtons. Then input the distance: 1, 2, 2, and 1. So to start, now upward forces is equals to downward forces. So upward forces equals to downward forces. The upward forces are 2, 4, 2. So 2 plus 4 plus 2 is equals to the downward forces RA plus RB. So that is 8. RA plus RB is equals to 8 kilonewtons. Now secondly, we are going to consider moment, and I'm going to take moment at a point A. The sum of moments at a point A is equals to 0. We're also going to introduce the concept of clockwise moment is equals to anti-clockwise moment. So at a point A, 2, 4, and 2 are all moving towards that direction, anti-clockwise. So also remember, moment is equals to force times perpendicular distance. So that is 2 multiplied by the distance 1 plus 4, 2 plus 1, 3, 4 times 3 plus 2 multiplied by 2, 2 and 1, that is 5. 2 times 5, which is no other force, is equals to, now, the anti-clockwise moment, that is going to be RB times this whole distance, which is 6, RB multiplied by 6. So that is going to be 2 plus 12 plus 10 is equals to RB times 6. That is 24 divided by 6 is equals to RB. So RB is equals to 4. Then back to this point, we said that RA plus RB is equals to 8. Since RB is 4, so that means that my RA is also going to be 4 kilonewtons. Alright, so the next step, we are going to divide this rod into sections. So for the first section, I'm going to consider a section up to where the first force is acting. So take a section whereby a section X whereby X is less than the distance 1 but greater than 0 from the starting point. So I'm going to consider that section. So once I draw it, so we have a reaction force RA. Now this distance is what I'm calling X, a distance X, not 1, since X is less than 1. Then at this point I'm going to name it Q. So at this point, this end, I'm going to have a moment, the one that is turning it, and I shall name it M of X. Also at this point, I'm going to have a shear force SX. So with that, we are going to repeat the same procedure as before. So starting, upward forces is equals to downward forces. So in this case, RA is my upward force and my shear force XX is downward force. So RA is equals to SX. That means my SX is equals to 4 kilonewtons. Secondly, we consider moment. So for this point, you're going to take moment at a point Q, and point Q is inside my rod. So the sum of moment at a point Q is going to be 0. Now, from RA, we're going to multiply it by X. RA times X, so that is a clockwise moment, is equals to this anti-clockwise moment, that is SX multiplied, since it has a point Q, it is a distance 0, so there's no need of writing it, is equals to, also remember, this moment is going towards this direction and RA is heading towards that direction, but MX is going in the opposite direction to that of A, and MX is a moment. So RA times X is equals to M of X. RA is 4X MX. Now from that, the M of X is 4X. But remember, our limit X is between 1 and 0. So at a point whereby X is 1, MX is going to be 4. Then at a point X is equals to 0, MX equal 0. So this is now the procedure that you're going to repeat, taking sections in between. So remember this, since I'm going to rub it. Now let us take another section. So a section X, whereby, so this time X is going to be less than 2 plus 1, 3. X is going to be less than 3. Then from this point X was 1. So you take from the last point, less than 3, greater than 1. Then you draw that section. So we have our 2 kilonewtons, less than 3, so we're not going to include the 4 kilonewtons. Then my reaction force RA from this point to this point is a distance of 1 meter. Then the whole of this has a distance of X. So inside here, my point Q, then moment X, and a shear force X. So this is now what you're going to analyze. Alright. So when analyzing this is now what you're going to analyze. So to start, upward forces equals downward forces. So in this case, the upward forces is only RA. So I shall have the R of A plus, as for the downward forces, we have the 2 kilonewtons and the shear force S of X. So RA is equals to the S of X plus 2 kilonewtons. So let us find the value of Sx. Sx is going to be given by Ra minus 2. Ra is 4. 4 minus 2. So that is 2 kilonewtons. So for the second section, Sx is 2 kilonewtons. Then secondly, we take moment at a point Q. the sum of moments at a point Q is equals to 0. So RA multiplied by all this distance x, RA is going in that direction, a clockwise moment. RA multiplied by x. So 2 kilonewtons is heading in the other direction, anti-clockwise. Then mx is also heading towards that direction, anti-clockwise. So is equals to the m of x plus, so for the 2 kilonewtons, we are going to consider this distance here with a blue mark pen. This is the distance that we are interested in. So it is going to be given by 2 into bracket the whole distance x minus 1. X minus 1. Then we said we are not going to consider the s of x since the distance is 0. Alright, RA is 4x. We want to make m of x the subject. So subtract 2x minus 1 is equals to m of x. 4x minus 2x plus 2 is equals to the m of x. So mx equals 2x plus 2. So our limits is 3 and 1. So at x is equals to 1, the m of x is equals to 2 plus 2, 4. Then at a distant x is equals to 3, the m of x is given by 6 plus 2, 8 kilonewtons. So that is Newton meter, and this is the distance in meter. So we have found for the second section. Then we look now at the third section. Let me rub. So for the third section, a section X whereby X is going to be less than 2 plus 2 plus 1, that is 5. X is less than 5. Then for the last part is 3. So we are considering this section less than 3. Then we draw that. So when drawing, you're going to draw starting from the beginning point. Remember that. A reaction force RA, a force of 2 kilonewtons, another force 4 kilonewtons. Then we're not going to include 2 since it is less than 5. So the distance here is 1, the distance here is 2, then the whole of this distance is x. So inside here, my point Q, I shall have my moment m of x and my shear force Sx. So upward force is equals to downward forces. In this case, the upward forces is RA. RA is equals to downward forces 2 plus 4 plus S of x. 2 plus 4 plus S of x. Make Sx the subject. So Sx is going to be given by RA subtract 4 plus 2, 6. RA is 4. So 4 minus 6 is negative 2. S of x negative 2 kilonewtons. Secondly, moment at a point Q is equals to 0 at a point Q. So we shall start. RA is going in that direction, that is clockwise. So RA multiplied by the whole distance x, then is equals to 2 is heading that direction, 4 that direction, mx also in that direction. So they're going in the same direction. So 2 multiplied by the whole distance x minus 1 plus 4 multiplied by x minus 2 plus 1, 3 plus the moment mx. Okay, so with that, RA is 4. 4x is equals to 2x minus 2 plus 4x minus 12 plus mx. Make mx the subject of your formula. Mx is equals to 4x minus 4x. That cancels out. Then I'm left with negative 2x, then negative 2, negative 12, negative 14, going to the other side, plus 14. Then our limits 5 and 3. So at x is equals to 3, mx is going to be given by 3 times 2, 6, negative 6 plus 14, that is 8 Newton meter. At x is equals to 5, the m of x is given by 5 times 2, negative 10 plus 14, that is 4 Newton meter. So that is for my third section. So lastly, I consider this other section. Allow me to erase. So a section X whereby, so this is our last section, x is less than the whole distance 6 but is greater than 2, 2 and 1, that is 5, less than 5, that section. So drawing it, you're going to draw the whole of it. So I have a reaction force RA, 2 kilonewtons, 4 kilonewtons, another 2 kilonewtons. So that is the distance 1, the distance 2, another distance of 2, then this whole distance x. So inside my point Q, moment m of x, and shear force Sx. Upward forces equals downward forces. So upward forces Ra, R of A equals 2 plus 4 plus 2 plus Sx, 4, 5, 6, 7, 8. So Sx plus 8, make Sx the subject. So S of x is given by Ra minus 8. Ra is 4. Sx is equals to negative 4 newtons. Sorry, this is a shear force. Negative 4 newtons. Then at our point Q, the sum of moments at point Q equals 0. So RA is heading in the clockwise moment. RA times the whole distance x is equals 2, 4, 2 and mx are heading in the anti-clockwise direction. So 2 multiplied by x minus 1 plus 4 multiplied by 2 plus 1, 3, x minus 3 plus 2 multiplied by 2, 4, 1, 5, x minus 5 plus the moment mx. Okay, so RA is 4. 4x equals 2x minus 2 plus 4x minus 12 plus 2x minus 10 plus m of x. So make mx the subject. Mx is equals to 4x cancels out, 2x plus 2x 4x, so negative 4x, then negative 2, negative 12, negative 10, that is a negative 24 plus 24. Then input our limits 6 and 5. So at x is equals to 6, mx equals 6 times 4, negative 24 plus that 0. At x is equals to 5, mx equals 5 times 4, negative 20 plus 24, that is going to give you 4. So we have found the shear force Sx and also the moment mx for all particular sections. So now we are going to take those sections and plot a diagram for them, both the shear force and the bending moment. So to do so, we are going to draw this at the top here. It is going to help us in drawing it. So at the very top, two kilonewtons, 4 kilonewtons, and another 2 kilonewtons, then the distance 1, 2, another 2, and a 1. All right, so I want to write the values that you got previously. So allow me to write. You had written them as we were working out the question. So for the first part, the section whereby x less than 1 greater than 0, we found Sx is equal to 4. Then for the moment at x1 and x0, the moment we had mx 0, mx 4. Secondly, at a section whereby x was less than 3 but greater than 1, the shear force Sx, then at x equals to 3, at x equals to 1, mx, so we had 2, then a 4, and an 8. Let me alternate that, 1 and 3. Thirdly, So let me just write it somewhere here. Thirdly, whereby x was greater than 2 to 5 less than 3, the shear force Sx 10 at x is equals to 5 at x equals 3 mx. There's a reason why I'm arranging them in that order. So 4, 8, sorry, 3, 8, 3 was 8, and 4. The shear force Sx was -2. And lastly, at a section whereby x was less than 6 but greater than 5, Sx was that, then x is equals to 6, x equal to 5, mx. So the shear force -4 at my point 6, 0, and 4. So double check and make sure you have that. Now you're going to start by drawing the shear force. So that being my reference point, that is not a good straight line. Okay. So for the shear force, the greater value I have is -2 and a -4. So 0, 2, 4. Third point, -2 and also -4. So for the first part, Sx was 4. So up to that part, Sx was a 4. Then for the second section, Sx is 2. So to this point, Sx is 2. Then thirdly, Sx -2. So you drop down that line. -2 is at that point. And lastly, Sx a -4. So it comes to that point, then you drop down that line. So you can shade the region that is wanted. And that is the shear force diagram. The shear force diagram. Now, for the bending moment diagram, the same case. So the greatest value I have is an 8. I have no negative value. So probably I can bring my axis slightly lower. Okay. 0. So for the section 1, at a distance x is equals to 1. So at that point 1, let me just draw the sections. 3, that is 5, and that is 6. So at section x is equals to 1, mx was 0. Sorry, this is 0 and 4. X equals to 0, 0. at a point x equals to 1, I've now divided 2, 4, 6, 8. So I have a value of 4. Then you draw a straight line. Secondly, at x equals to 1, the same value 4. So at that point, x equals to 3, mx is 8. So 8 is there. Then you draw a line joining that point. Thirdly, at x equals to 3, I have 8, the same point. X equals to 5, mx is 4. So 4 is approximately there. Join the two. Remember, you're going to draw this with a straight line. Then lastly, at x equals to 6, we have 0. At x equals to 5, mx is 4. So that point, join that, and then we shade the wanted region, and that is it. So the Newton meter distance is in meters, same case distance in meters, and that is my bending moment diagram, and that is it. If there are any questions, kindly write them down at the comment section. Thank you.